Are we live? Well, I hope we are anyway. Good morning, everybody, and thank you for joining myself and George and David and Stefan from Emesent. This webinar is going to go through all the functionality of the Hovermap in the modes you can utilize it with, including using it on a drone. Myself, my name's James.pick. I'm the Business Development Director for Survey and Construction at Copters. I'm joined with my colleague, George Byrne, if he wants to introduce himself.
Hi guys, George Byrne here. I'm the Business Development Manager for Inspection around the UK.
And we're also joined with David Jagger, who's the Sales Director on the EMEA side for Emesent, and also Founder and CEO Stefan. So thanks for joining me, guys. I'll hand over to you guys to give us a really good introduction to your products.
Great. Thanks, James. It's a pleasure to be here and to present to everyone this morning. Really excited to be partnering up with you guys to bring Hovermap to this region. So as mentioned today, I'm going to give a quick overview of who we are and the product, and then we'll dive into some use cases and examples, and I'll hand over to David as well to talk through some of those use cases. So just briefly on the company background. So we're based in Australia, background in robotics and autonomy, more than 10 years of R&D at CSIRO prior to forming Emesent. So CSIRO is the sort of national research organization in Australia. And in that group, we worked on, myself and co-founder and a couple of others worked on drones and drone autonomy and SLAM-based LiDAR mapping. And then we founded Emesent to commercialize some of the technology we developed there, particularly the Hovermap product. So we've grown, we're more than 100 staff now and continue to grow, but we do have a presence around the world through our resellers, and we're obviously selling to customers around the world. Our core expertise are still sort of based around the robotics and autonomy side of things, focusing on drone autonomy, but also expanding into automating other kinds of robots, and obviously expertise in SLAM-based LiDAR mapping and autonomy. Sorry, just getting the slides to behavior. So, I mean, in terms of our company vision and mission, we're all about autonomously digitizing challenging and inaccessible areas, and obviously using robotics and autonomous systems to do that, as well as SLAM-based technology, because SLAM can operate in areas where there is no GPS. So what we've identified is many use cases and industries that have this challenge of needing to capture data in areas that are hard to access, don't have GPS, don't have reliable communications, and often don't have existing maps into these environments. And you can see some examples down below, and we'll talk through some use cases in which address some of these problems that we've solved with Hovermap technology. So just to briefly, what is Hovermap? If you haven't sort of come across it before, it's basically a 2-in-1 LiDAR mapping and autonomy payload. It's a SLAM-based system, so we use a SLAM algorithm in real time running on board the Hovermap payload. When it's mounted to a drone, it's using the LiDAR data in real time, running the SLAM algorithm to estimate the state of the drone, so that's the position and velocity. And then on top of that, we have an autonomy stack, autonomy layers, which use that data to provide autonomous flight, providing collision avoidance, path planning, and navigation, allowing the drone to navigate beyond line of sight and communication range in these challenging environments. It's also storing all that data on board, up to 12 hours of onboard data storage. And then there's a post-processing step to convert that raw data into the accurate 3D point clouds that you'll see. So this video, and apologies, this is probably going to come across a little bit jerky, but just gives an idea of what the system is capable. We have a lot of customers in the underground mining space, and that's one of the strongest use cases for our system. This just gives you an idea of what the environments are like in an underground mine and what the system has to cope with. So what you're seeing is some video from an onboard GoPro. You can see the Velodyne LiDAR of Hovermap spinning out in front of the drone, and the drone navigating these really tight, confined spaces, obviously without GPS and without communication range, and capturing this very rich data in these environments. So this is a stope which has been scanned probably within sort of 5 minutes of flying into this environment beyond line of sight and communication range. And it's used every day in these kind of environments to capture data that just was not possible before, for doing volume estimates, convergence monitoring, looking for rock bolts to make sure that the roof support is adequate. And as you can see in this example, going into areas that have had significant rock falls and are sort of a safety hazard. So I won't go into too many details with the mining workflow and examples today. We'll focus on some other use cases, but I just wanted to show what the system is capable of in those challenging environments. So as I mentioned, Hovermap's designed as an autonomy and mapping payload, and we do offer 3 levels or 3 ways of using it. First of all, it's just, you can use it as a mapping payload. So it can be used on or off the drone, like you'll soon see, as a standalone mapping payload. And in that mode, it can be carried, mounted to a vehicle, or mounted on a drone, but it's not actually helping the drone flight. And while it's mapping, it's also actually streaming a low resolution point cloud to a tablet, so you can actually view the point cloud as it's being built up in real time. Then we have our line of sight mapping and autonomy capability. So in this mode, a human is sort of flying the drone with typical RC joysticks, controlling the drone, but Hovermap's providing pilot assistance. So it's forming like a virtual bubble around the drone to do collision avoidance, and it will prevent the operator from getting the drone too close to anything. And it also provides the GPS denied flight stability. So if you're familiar with flying DJI drones, for example, it's like having DJI P mode or position mode hold, even when you lose GPS. And then thirdly, we have our full autonomy capability, which is, like you saw in the video, flying beyond line of sight and communication range. And that's achieved simply by placing waypoints in the live streamed map. And you can see sort of the animation of the tablet there, a map being streamed back to the operator during flight. Quick video showing a typical sort of use case, again, in underground mine. You can see it's a quick release plug and play device, so you can quickly mount it onto the drone. Once it's up and powered and spinning, that live stream the map is streamed back to the tablet's interface. And then in this case, the operator is placing a waypoint somewhere way off in the distance, beyond the bounds of that map. So obviously, in this case, it was an inaccessible area. He didn't know which direction that the tunnel was going to be going. So he placed a waypoint somewhere off in the distance, and that gives the system some guidance of where to try and explore and reach. Once the mission's launched, it's on its own, flying autonomously, doing collision avoidance, following the tunnel, trying to reach that waypoint which was placed. While there is a link back to the operator, you can see that map streamed back and developing. But in environments like this, it doesn't take long. Go around a few corners and you lose that communication link, and then the system is obviously fully autonomous on its own, trying to reach that waypoint, avoiding obstacles along the way, constantly monitoring its own battery health as well, and estimating the energy needed to safely return back to base. And if it hits that low battery threshold, it will abort the mission and return back to the start point. In this case, it's reached the end of a dead end and realized it can't progress any further, so it's making its way back to the takeoff point. When it comes back within the communication range, you'll see the map is streamed back to the tablet, and the data that's been captured while it was out of comms range is fed back to the operator, who can then review that, decide whether there was some missing area, and send the system out again. We can keep doing this to keep exploring and mapping an area. And then this is an idea of some of the data captured from that flight. So you can see incredible detail captured all beyond line of sight and out of typical access. So that's drone use, but like I said, Hovermap is extremely versatile, and it's designed as a plug-and-play device, so you can very quickly and easily remove it from the drone. We provide a number of accessories to mount it, allow mounting onto vehicles, other robots, and a protective cage for lowering it down vertical shafts as well. It doesn't always make sense to use a drone if not necessary. So this is a key feature of Hovermap, that it's really designed to be plug and play. When it's mounted onto a drone, it auto detects the type of drone that it's connected to, and it self-configures to make sure that it's ready to fly with that drone. And I'll talk about the different drones that we're compatible with in a minute. The backpack accessory is extremely popular because you can actually store and carry Hovermap and transport it in the backpack, and then mount it to the outside, and batteries are provided to power the system, and it gives you a hands-free scanning capability as you're walking around for mapping. Next slide. Come on, PowerPoint, there we go. And yeah, just to mention the drones we're integrated with, first of all, the DJI line of enterprise drones. So this is the M300, which can carry Hovermap quite comfortably. And then we've also recently adapted the Autonomy to function with the Pixhawk range of autopilots. And the first one we integrated with is a drone from AceCore, the AceCore Zoe, made in the Netherlands. So both very reliable, capable platforms, suitable for a variety of applications. And also importantly, they can both carry both Hovermap as well as a traditional gimbaled camera for doing inspection. So in many cases, Hovermap is doing the drone autonomy, getting into hard to reach areas, but you can still carry an inspection camera to take inspection images. We can also colorize the point cloud. So we have an option to add on a camera module, which is aligned and calibrated to the LiDAR reference frame. And then we can project that color information to provide additional context. And the example you're seeing here is a stadium mapped in the US. And this was all done in a couple of flights on an M300 and a couple of walking scans as well, combined into a single scan. The workflow is also designed to be extremely easy to use. So like I said, you capture your data, you transfer the raw data to a laptop, run the process, which takes around 1.5 times the capture time. And then we export standard formats, which can be ingested in traditional CAD or survey tools. We're also sort of pride ourselves on the quality of the data that we produce. The density, because of the Velodyne LiDAR that we use, producing up to 600,000 points per second if it's in dual return mode. Because the system is always moving, it's obviously seeing the scene from many viewpoints. And because that Velodyne is rotating, it provides omnidirectional coverage. It's spraying points in all directions. So in terms of relative accuracy, it's a SLAM-based system. So accuracy does vary on the environment sometimes, and the method of capture. But for typical environments, we see a relative accuracy of around plus minus 20 millimeters. But in actually works better in tighter and closer environments because the SLAM solution has more to work with, and the range errors or range noise is lower at shorter ranges. So we can see measurements of up to around plus or minus 5 millimeters. And then we also have a merging workflow which allows you to combine multiple scans. So if you've been flying and walking with the system, you can run it through our merge process, which is a non-rigid merging solution. So it actually improves the individual scans as they are merged together using our SLAM algorithm. So just onto a couple of use cases. There are very many and varied, but I'll focus on a few, and these are just a few highlights in this slide. I've mentioned mining, and there are many use cases in underground mining. I'm not going to go into any more detail, but just sort of indicate that we do have a lot of case studies and details on our website if you'd like to find out more. One application which is related to mining is hydropower tunnels, and it's been used quite widely to do inspections of hydropower tunnels and overflow tunnels. And this is an example of an area scanned for inspection purposes. And again, you can see the level of detail that's been captured in areas that would otherwise be almost impossible to reach by flying inside these tunnels and the exterior of this overflow area. Another popular use is inspection of bridges. Drones are more and more widely used for bridge inspections, but there still is a challenge of flying underneath the deck of a bridge where GPS can be lost partially or totally. So Hovermap allows flying safely underneath those environments, capturing the 3D point cloud, and like I said, now carrying an inspection camera to to match inspection images to the point cloud. As you can see, that in this case, the point cloud's been run through a typical workflow to convert from a point cloud to a model of the bridge. And just a few other examples of bridges that have been captured, including very complex 3D structures. And again, this can be a combination of walking and flying scans. Also many uses in oil and gas. This is an example of a exploration rig which was in for retrofit. So took the opportunity during basically a lunch break. That's the only chance that our team had. They had an hour window, so they went out and did a flight of around half an hour and a walking scan of around a half an hour. And this is the data that was captured in that really short period of time as a proof of concept. So it's not 100% coverage of this entire rig, but you can see pretty well covered for that amount of time. And I'll skip a bit forward so you can see some of the detail, exterior, interior. Again, combination of those two modes of scanning combined into one. And then other oil and gas facilities include storage facilities. This is a plant in Indonesia, again, combination of walking and flying scans, including the ability to fly inside these storage tanks. And again, the GPS denied flight and collision avoidance making that possible. Also have a number of customers who are using it for bulk storage facilities or indoor stockpiles. And again, traditionally these are quite hard to survey, require walking over the material that's been stored or other forms of trying to access it. But with being able to fly safely in these indoor environments, within a couple of minutes, these extremely detailed scans can be captured, obviously providing very accurate volume estimates for whatever's been stored in these facilities. And also just a great use case for LiDAR over something like photogrammetry, because obviously often these areas are dark inside, and photogrammetry can be challenging to use in these dark environments. A couple more examples. One is a steam turbine room captured by partners in Indonesia. And again, just showcases the ability to capture extremely complex 3D structures in a short amount of time. So this was done by walking through this environment in around half an hour. And then the scan was used to convert from a point cloud to a BIM model for this facility. And another one I really like is naval or vessels scanning. So we have the US Navy, for example, using Hovermap to scan their vessels. This is not a US Navy vessel. This is a museum a vessel, which is actually in a museum in Brisbane. Took the opportunity to fly around the ship and walk parts of the interior. Again, combining those scans to produce an extremely detailed exterior and interior as built. And for naval applications, it's around that sort of as built prior to a retrofit to understand what actually the current state of the vessel is, or for training purposes in sort of virtual reality environments. So I'll just flick through this one or two videos showing again the incredible detail that's captured from walking and flying around these kinds of very complex structures. And then we have many customers using Hovermap for typical above ground surveys, including power lines and many others. And then I'm going to hand over to David to talk through some of the AEC use cases. David, I'll hand over to you and let you introduce yourself and talk through these.
No, thank you. Okay, so I'm David Jagger, as we've stated already, Sales Director for EMEA. Just to reiterate a couple of points here, because we have developed within mining, coming into more AEC areas is relatively easy in terms of that transition. The benefit of the Hovermap is we have the ability to do the flying, walking in the building, walking around the buildings in different areas very, very quickly and efficiently with the same device. So this model here is it was a test site. This is actually scanning the fascias east, north, south, and west, and then multiple scans inside to take the detail of each floor and then the detail of the roof. So our technology doesn't replace photogrammetry, it doesn't replace terrestrial LiDAR. It complements those two technologies, and it allows you to use it as a tool, as an add-on to your toolkit to grab those areas GPS denied, or just areas which just physically can't actually have the terrestrial. So if you can skip on forward for us, please, Stefan. Right, another example here, the Centre of Arts. This is using the colorization, again, a drone flight. Pretty it explains itself here, 50-minute drone flight, 1 hour internal walk. And if we can skip to the next stage, what you're actually able to provide from that is taking the data into different applications. This was from Point Cloud, Recap, and then Revit, and it enables you to give you a very quick, very efficient 2D, 3D BIM modeling. Right, as-built offices. Now, this is always an interesting one. In terms of scanning outside and inside, again, very quick and efficient. And we've been working with partnering up with different software applications. So both Point Fuse, Point Cab for different applications. So Point Fuse is very good as a modeling tool for new as-built office systems where you want to go in there quickly and efficiently scan. This can be done with terrestrial LiDAR in a lot of cases, but the benefit of SLAM, especially walking, is that it's that time taken to take that data. It can be done in the evenings. It can be done, as I say, on the oil platform that Stefan mentioned during lunch hours, lunch breaks, and it's got less interruption for the staff within that building. So it's a flexible tool to, as I say, add to the value proposition of the existing products you have. Again, carry on for me. Right, one more example here. This is of an elevator shaft. This is more of a proof of concept. We mounted the Hovermap magnetically to the top of an elevator and rode it up and down. It's given us some deliverable drawings that can be produced in Revit. Not complete because it was a proof of concept, but again, showing the area there. These typically don't exist in plans for a lot of as-built buildings. There are no plans for them. There are no accurate plans. And on the next slides, I'll explain that a little bit further to you about how this is a value. But before that, I wanted to also cover one of the key areas, especially within surveying, is actually the ability to pick up and do road scans. Now, the interesting thing with road scans is SLAM has recently has been failing in this area. And the reason being is because you can't pick up what the surveyor needs. You can't pick up the road markings. You can't pick up, and you can look at the bottom right-hand side here. You can see the small triangle. This is the spray marks from the surveyor, the control points. That data typically isn't able to be picked up, but because we've developed a solution from mining and we needed that data within the mining to provide the service we do, for road surveys, we are picking up sufficient data. Now, I'd like to individually, if anybody wants to go through this, we are getting plus or minus 50 millimeters on a road scan with our standard product, but we have some rather efficient workflows that I'll happily go through with anybody individually, and we can reduce that accuracy even further. The only way of testing in terms of SLAM is to look at the drift, and road scans are notoriously hard, and the reason being is because you don't have a ceiling. You don't have walls like inside a building or underground. So getting that accuracy throughout the whole of the scan, plus or minus 50 for a surveyor, is important, and we can achieve that, and we can actually improve on that as well with the workflows. Now, other areas such as more complex areas, and this is quite important both for the walking and for the drone aspects. Heritage, for example, in terms of heritage, a lot of buildings, there's a lot of risk associated with flying around many heritage buildings. They don't like drones. With AL1 and AL2, it gives us the ability to fly around those areas safely. We can fly around a building out of line of sight, and we can also fly collision avoidance. So this gives us an open up to new markets of that scan to BIM for heritage sites. You can't use something like Point Fuse for this, but you can use, for instance, Point Cab, and then putting that Point Cab application into Revit and vectorizing it and bring that through. And again, I've got some examples I can show you of heritage work we've done and merging both the inside and the outside. Now this one, again, when you're talking about as-builts, many a time different applications. This particular application was for a company looking at building the rails, and these rails were going to be on the stairways. Now, there was no plans for that particular model, but a 3-minute scan and then dropping those plans into Point Cab provided enough information to do some validity checks on the handheld drawings and measurements that had been done. And if you skip forward one slide, so a couple of things you'll notice. The handheld drawings, bottom left, you can see the handheld drawing, and on top of that is actually laid the slice through of the stairs that was done with the Hovermap. The handheld drawing missed one step. Now that seems minor, but when you're looking at designing and developing rails, that's actually relatively important. And again, on the left-hand side on the picture, the handheld drawing put the window actually in the wrong place. So it's just a way of actually checking. A 3-minute scan through the whole project allowed them to check and just adjust and ensure that the rails that were going on the stairs and each platform were correct and fitted properly. Right, another area, this is probably not going to run very well in terms of the video, but it's in change detection. So there are, especially within the UK, a lot of projects at the moment to do with riverbank erosion, and again, also erosion rockfalls. In terms of the heritage work for path monitoring, last year during COVID, that was a massive problem when the heritage parks were open again and people were just storming around, not staying to the footpaths, and there was damage done to the bluebells, for instance, and the grass. So monitoring of those can be done with photogrammetry. The complement of this product on the top right-hand side of the video there, that is of Vineyard. Now, the rockfall above that is monitored by photogrammetry, and they do once a month, they do a full photogrammetry scan of the 3 miles. What they're now doing is they're looking at implementing SLAM to do a weekly scan. That gives them a lot easier, a lot faster process to do, just to watch and just to do a quick change detection. Now, they still use the photogrammetry and they use photogrammetry for the work, but they can now do a weekly scan rather than actually once a month. Do you want to go through the key benefits, Stefan, or should?
Yeah, thanks, David. No, that's a great overview of some of those use cases. I mean, this is the final slide, and then we'll move on to questions. But I just wanted to sum it up with sort of the key benefits that we hear time and time again from our customers is, first of all, the speed of capture, like you've seen in some of these examples, being able to capture very complex places and structures relatively quickly, and then the processing time is relatively quick as well compared to photogrammetry, for example. The drone autonomy is a significant game changer in areas where previously were inaccessible, too dangerous to send people, or if you need to do something in a repetitive way, then autonomy provides obviously significant benefits in that. The quality of the data that we are able to produce, again, I think you've seen some great examples there. Extremely robust and reliable SLAM solution, which is providing that. And then, the versatility, the Swiss Army knife kind of capability of Hovermap, that it can be used on a drone, off the drone, in so many different ways. Again, this is something we hear often from our customers that they enjoy and they value. So that's it from us. Really looking forward to some questions, and thanks very much.
Yeah, thanks for that, guys. That was really informative, and I even learned quite a lot from that as well. So that's really, really great. In terms of questions, if anyone does have any questions, then please feel free to put them in the questions tab at the top of the screen on the right-hand side. And I'll be more than David and Stefan will be more than happy to answer them going forward. Do have one from Wayne, who's asked, do you have any incidents in the mines with the drone? Have you had many crashes? And the second question is, how long does it take to complete a stope mission?
Stope obviously depends on the size and complexity of the stope. Typically, 3 to 5 minutes of flying inside the stope is enough to cover it. Like you saw in the video, the setup and pack up time pretty short as well. So much quicker than traditional CMS-based scan, especially if you have to move barricades out the way to get access for that sort of CMS-based scanning. Yeah, things go wrong in mines for sure. I mean, there's very challenging environments. We had a customer a couple of weeks ago who had reported that their system was absolutely smashed by a huge slab of rock which fell down and destroyed it in the stope. But they were actually quite pleased because it meant nobody was nearby when that happened. So yeah, it's a very challenging environment. Things go wrong, and it's still the value of the system still is worth it to suffer those kind of losses.
I think also to mention we did have that in one of the slides, as we do obviously the product can be used in forestry as well, and it's possible to fly it between trees. Now, again, operation between trees, you have different environments. So I can tell you as well, one of my colleagues in America pretty much had the worst sound in the world when he heard these blades turning into a rotary mower on some very fine twigs, but the drone made it back. So yeah, we have near instance that with, but in terms of measurements, 3 millimeter visibility, pretty much it's good operation flying between trees and flying underground. And
yeah, just to mention in that instance, that's when he had the collision avoidance disabled, so he learned.
Oh yeah, sorry, he was flying. Yeah,
he learned to keep it on.
And another one from Wayne as well. He's just asked in terms of the drone flying of it. Which app do you use on it? Is it available on the smart controller? Do you have to have an external tablet? How does that work?
So we have our own app which runs on the tablet for the autonomy function. So when you're using Hovermap in autonomy mode, it allows you to set the waypoints to most of the functions that a sort of a DJI-based app would give you are replaced by ours. If you're flying above ground and want to do GPS waypoint-based mission, that's not part of our app. So you'd use a sort of a third-party app to plan your GPS sort of waypoint transects. But if you're using it in autonomy mode, then yeah, we have our own app that covers that.
And if you're flying if you're actually L0, so you're walking or backpack or whatever, then you can use any phone app and just link on and see the real time through any phone, through any browser.
Excellent. And Daniel's asked a similar question. Is the unit completely independent of the drone, or is it actually integrated into the aircraft's SDK port?
It's independent mechanically, so you can take it off. We connect in signal and power, so we tap off the drone's battery supply to power it, and we are sending the signal into the onboard through to the flight controller. So on the DJI side of things, it's through the onboard SDK capability, and we're sending very low-level commands. So I mean, Hovermap is the full autopilot. All we're telling the drone to do is tilt at certain attitude angles. And on the Hydropilot's integration is pretty similar. So it's I think that answers the question. Yeah, mechanically it's sort of plug and play, click it in, and then power and signal into the drone's flight control system.
Thanks, Stefan. And one from Simon on the autonomy side. Do you have a tested flight safety diameter that the system performs to for flight collisions?
Yeah, I mean, it's a function of the size of the drone, because obviously we do integrate with a different number of drones. So you can, during flight, you can change the size of that safety bubble, but we have a minimum threshold. So we leave at least, I think with the latest setting we have is about 50 centimeters sort of beyond the blade tips. So on an M300, you could squeeze through, actually it's a bit bigger than that. On the M300, you could squeeze through something just over 3 meters, 3 meter wide gap. On the M210, it's a slightly smaller drone, so you can get through some smaller spaces. That's when it's doing its own sort of path planning and flying. When you're in pilot assist mode, you can actually squeeze it through some even smaller gaps, because obviously then there's not a risk of it not being able to come back out through a small opening that it's found its own way through.
Thank you. And one from Matt. What does the evolution of Hovermap look like? Smaller, lighter, higher resolution, better accuracy?
Yeah, I mean, all of those. I mean, the one limiting factor for us is the LiDAR. I mean, we're relying on off-the-shelf LiDARs. We use the Velodyne puck at the moment. We're always evaluating other devices as they come on the market. So that's one limitation. But yes, compute power is getting better, and smaller form factors. LiDARs will become smaller and lighter, so we'll take advantage of all of those things. And obviously, keep improving our software independent of the hardware as well. So we're always improving the autonomy layers, autonomy levels, and the robustness of the autonomy independent of the hardware that's running it as well.
Yeah, I would say the evolution at the moment is very much on those software, on the software side, which is essentially it's available. So the all units, whether it's purchased as AL0, 1 or 2, all units are capable of just updating to the higher version.
And that can be done just with an unlock, not having to send the unit back.
Yeah, exactly.
Just a question for me, guys. Environmental constraints. What's obviously the best environmental conditions to be flying it in? Obviously, light, dust, wind, rain. What's the optimum for you guys?
Light. It's independent of light because it's a LiDAR, so it's active light, so it's not affected by external lighting conditions. Dust, it can handle rather heavy dust to the point where it's actually hard for the pilot to see it within a couple of meters. But that does depend on how close the walls are beyond the dust, because it has to obviously penetrate through the dust. We do have a dust fail-safe built into the system, so if it flies into part of a mine and the downwash kicks up a lot of dust, it's monitoring a couple of things, and if it detects that situation, it will actually abort the flight and fly back home safely to avoid being trapped in the dust. Moisture, two aspects. Obviously, there's rain, moisture dripping from the sky. The IP rating is, I mean, it's not rated to fly in the rain. When it's mounted under the belly of the drone, that definitely does help. So we have customers who've flown it in sort of light rain, and it's come back in good shape, but it's certainly not designed to be flown in the rain. So the drones are actually better IP rated than the device itself. Another challenge which sometimes can present itself is inside a confined space like a stope, that you can have a microclimate, so you can actually have water vapor collecting at the top of the stope if it's not ventilated, and that water vapor can absorb LiDAR. So that's a challenge that is sometimes encountered, and obviously we train our customers what to look out for and to make sure that they're aware of those particular kind of situations.
I've got a question from Herbert. What's the endurance of the Hovermap on the M300?
On the M300, it's around 25 minutes. Again, it depends slightly on the flight characteristics, how you aggressively you're flying and maneuvering, but it's around 25 minutes when it's carrying Hovermap.
Got one from Derek. I'll probably answer this one. If I only fly the drone inside a building or a mine, no access to airspace, can I use this system without a drone license? Technically speaking, yes. If you are flying in an environment where there's no chance of that drone leaving and entering into airspace, then it will be covered under the individual's and the company's own risk assessment and procedure, basically. The next question is, how accurate is it compatible or comparable with the Faro 3D scanner for indoor volume measurements?
Okay, so yeah, we can talk about the accuracy. It doesn't replace something like a Faro, but in terms of can we just get a qualification from him in terms of when he says how accurate? Mm-hmm. What exactly is he actually after from that Faro?
If you can put just a little add on to that question below, we can hit it back to David. He'll be more than happy to answer it. Next one from James. Does the kit provide a fully 360-degree map of the room area that it's in?
Yes. I mean, because as you see, we take the Velodyne and we rotate it to give that extra axis of field of view. So it does provide a full spherical field of view. Obviously, when it's on a drone, there's a small blind spot caused by the drone, but because you're moving around and maneuvering, it basically fills in everything, and that's critical for collision avoidance as well. Obviously, the drone can move in any direction, so it's important that it sees in all directions, and then for mapping as well, it covers the full spherical field of view.
Cool. We have one from Mike. Are there any limitations on size of coverage and or time taken within a typical scan?
Do you want to cover that one? I can cover you.
I mean, from a drone perspective, obviously, area that you can cover is one factor is the flight duration of the drone. The other one is SLAM. I mean, it is a SLAM-based system. SLAM is a incremental estimation, which is subject to drift. So it's not the right solution to do very long linear assets and expect a globally accurate solution. At the moment, in the future, we will be able to use GPS to constrain the SLAM drift over those long distances. But yeah, it's best suited for complex 3D challenging kind of structures, not for doing broad acreage or long linear assets. There are other systems that can fly higher, fly faster. If you're ready, if the focus of the objective is really about coverage, then there are other sort of drone lidar systems which obviously don't provide collision avoidance. And when you're flying high and fast, you assume there are no obstacles, so the collision avoidance is usually not required.
Yeah, and just to add to that, it's essentially, yeah, so some of the other technology flying higher, for instance, on a forest scan, yeah, use that technology, not this product. But if you want to zoom in on a certain area of that forest and you actually want to take the detail in that forest, then using our product on that particular section is useful. To answer the question on time taken for a typical scan, 20 to 25 minutes on any scan is a good size to actually keep to, and the reason being, as Stefan said, there's a drift, but it's also the output in terms of that data file size and actually management of that file afterwards. You saw the scan of the building that was flown. That was flown on 4 flights, north, east, south, and west, and then it was actually multiple scans inside. The data taken very quick, and then using our application to merge that and align the data afterwards. So it's faster and more efficient to do it in multiple scans rather than actually just one long scan, because you'll have inefficiencies on the drifter, etc.
Thanks, David. And I think this is the last question from Daniel. Can we colorize the point cloud using data captured from a second payload attached to the M300, for example, the H20 camera or the P1?
No, not at the moment. I mean, the challenge there is we need to know the pointing or the gimbal angles very accurately relative to the LiDAR. So for now, the colorization is purely possible through our fixed camera, which we mount underneath Hovermap. Yeah, I mean, that's to get that alignment between camera and LiDAR precise enough with a gimbal camera is obviously a very challenging problem.
I'm working with several companies at the moment looking at actually merging separate 3D images with our data. So there are several companies out there working operations. So again, feed through afterwards, and I can put you in contact with those companies.
Yep.
That's brilliant. Well, I think that's been a really great session of Q&A. Clearly, a lot of interest in a product like the Hovermap. I've used it a good multiple times with David and myself, and it is a really easy product to use, really easy workflow, and the data from it really speaks for itself. And just some of the few examples which you guys have shown on this webinar really shows that the power of a product like this. I don't know if you guys, any of you wanted to add anything before we sign off?
No, yeah, just again to say thanks to you for hosting this. It's been amazing working with you, and excited to carry on with that relationship. And in terms of reaching out, yeah, I think I did flash up some contact details in my last slide, but definitely reach out to the Copters team or to David, or have a look at either of our websites. There's plenty more information, and yeah, we'll obviously get back to you as quickly as we can with to answer any questions.
Absolutely. From my point of view as well, thank you very much. Well, I'm looking forward to working with this Copters team. We've got some exciting projects. The question we didn't answer to do with the Pharaoh, let's come back to that person straight afterwards. If he's still not done the answer. But again, please reach out to us, and we'll answer any more questions you need later on. Thanks a lot.
That's brilliant. Thanks, everybody. Yeah. Thanks, everybody, for joining us, and we'll speak to you all soon. Cheers.